In this setup tutorial, we're going to perform some calculations for a North Pacific simulation. Now, I already have a grid that I'm interested. It's stored in my directory called grids, and it's called the npacific grid. So the first thing that I'm going to do is I'm going to configure this grid in my R&T toolbox, or actually even better, I'm going to create a new directory in my home directory for this application. I'm going to go in cd roms examples, and I'm going to create a directory called npacific where I'm going to do all my North Pacific application. In this directory, I'm going to create a couple folders. The first folder is called input, and this is going to contain all my files, the netcdf files and input files. Then a directory called matlib that contains all my MATLAB work and supporting files. A bin directory, the scripts directory. I like to have scripts, and an output directory. So I just do that. At this point, I go in my input directory, and here I'm going to make a copy of the grid file that I want to work with. Grids, it's called npacific, just so that I have everything in one place. And so now I have in my input directory this grid. The next thing, I can go in my matlib, and here I want to start creating my netcdf files. As we did before, really all that I need to take is from my home directory. I go in the roms-nc file toolbox, and I can copy all the main ncfiles.m in this directory here. And so now I'm almost ready to go. I can go and then in the MATLAB directory here. Oops, sorry. And I can go in ROMs examples, and I'm going to go in North Pacific -matlib, and I'm going to fire up MATLAB. First thing, I'm going to configure the North Pacific grid by typing rnt config, which gives me the path of my configuration file, which is here. I'm going to open that with VI, and I'm going to look for npacific. I have a couple of these. So here's my npacific, and I already put here the path to the grid. Okay. This is actually the North Pacific, so I'm going to change that, the North Pacific. I want to have 30 layers for this grid. I want to stretch the S coordinates to have a higher resolution at the surface, so theta s equal 5. I'm going to have a minimum depth of 30 meters. That's how when I design the grid. And I'm going to have the bottom boundary layer, sorry, the bottom coordinates to be also a little bit resolved, but just about 0.4 in terms of this parameter theta bottom. So with this done, then I can save that. I can load my grid, and I've called that npacific, and I can make a plot of the grid bathymetry, for example. This is the grid bathymetry. So you can see it's pretty smooth. I set the minimum depth of about 30 meters and a maximum depth of 4,500. I can plot, for example, the average resolution of this grid, which is going to be 1 divided grd.pm divided 1,000, so that it's in kilometers. And you can see it's pretty coarse grid. You know, the average resolution should be about 65 to 70 kilometers. So it's a pretty coarse grid, but it will give us an example of the North Pacific simulation, and it's going to perform quite well. Another things that I can check is, for example, the R value, since I smoothed the topography, R value of grd.h. And you can see that on average it's below 0.3, and it's higher in the coastal regions where you have the continental slope, of course, and weaker and small in the ocean interior. So this is the grid for which we want to create our initial condition. And so now all I need to do here is, after I copied my main scripts, is to go in main ncfile.m and to set the configuration parameters. in this case the name of the grid, which I already set here to North Pacific, and then the output directory for all the netcdf files. And here I want to store this in the input directory, which is one directory up. And that's really all I need to configure in this particular case. So then I can just run this main NC files and wait for the files to be generated. This is the setting that I want, so I press return. And in this other directory, here I'm in the MATLAB directory, I can go one up, and now if I do an ls -l of input, I see that I have my grid file and the climatology file, which is currently being created. It's now doing the geostrophic velocities, and at this point we only have to wait for this script to finish, and then we can proceed to the next step, which is to configure and compile the ROMS model to run this particular grid. Now while we wait here, let's go in the edit directory and fire up well, actually there's not much more to do, so let's just wait for this to finish, this computing geostrophic flow. But it should there shouldn't be any problem. Once again, if you want to find more details about the creation of this file, you refer to the previous tutorial or the section on creating forcing climatology and initial condition files. So now it's creating the initial condition, and that's very trivial because it's just taking one set from the climatology, the open boundaries. So here if I do now ls -rtla, you find that you have the grid, the climatology, the initial condition and boundary files are done, and it's now finishing the forcing file. And so anyway, it's going to complete this run, and you will have all the necessary files here in the input directory. And so at this point we just can proceed to the next step. Okay, thank you.